Hi, the last objective that I want to cover here is how to solve simple trig equations. So to solve a trig equation, we're going to try to find the angle whose trig value is given. These are going to be very simple based on the unit circle at this point. We're going to get into more complicated trig equations later on in the course, but for right now it's just really going in the backwards direction. So we want to find two solutions of the equation, and we want to give our answer in both degrees and radians and not use a calculator. So if I want to find sine theta is equal to 1/2 and I'm trying to find the angle theta whose sine is 1/2. Well, if I know the unit circle really well, I don't even have to look at this, but if I don't, I might want to try to think about the unit circle and how it can help me. So if I'm trying to find an angle whose sine is 1/2, that is, I'm trying to find an angle whose point on the unit circle has a y value of 1/2. Well, we see that here at pi over 6. So one solution would be theta is pi over 6, or in terms of degrees, we could also write that as what? 30 degrees. Well, the thing that we just talked about with reference angles, we know that any angle whose reference angle is 30 degrees would also have a sine value of 1/2, except for possibly the sine, S-I-G-N, not the S-I-N. So I need to think about another angle in a different quadrant whose y value is also positive 1/2. Well, we know that sine is positive in only the first and the second quadrant, because for y to be positive it has to be above the x-axis. So we know that there's also an angle in quadrant 2 whose sine is 1/2, and sure enough that is 5 pi over 6, because that has a reference angle of pi over 6. So another solution would be 5 pi over 6. In terms of degrees, that would be 150 degrees. Okay. Now, what about cosine theta is negative square root of 2 over 2? Well, cosine here is negative. Well, cosine is negative where x is negative, which would either be in quadrant 2 or 3. So we know that the square root of 2 comes from having a reference angle of 45 degrees. So a reference angle of 45 degrees we see here is 3 pi over 4, or 135 degrees. So theta would be 3 pi over 4, or 130 degrees. I'm sorry, 135 degrees. What's another angle? Well, one also that has a reference angle of 45 degrees in the third quadrant would be 225 degrees, or 5 pi over 4. So I'm going to have to move, oops, the wrong thing I'm moving. Let me move this down. So theta could also be 5 pi over 4, or 225 degrees. Now certainly you could do the negative of some of these angles, but we'll just stick with the positive for now. And you can also do multiples of 2 pi. Cotangent of theta is negative square root of 3. Well, what would that be? I would probably put this in terms of what? Tangent of theta would be equal to negative 1 over the square root of 3, or negative square root of 3 over 3. But if you think in terms of sine over cosine, where would we get the 1 over the square root of 3? Yeah, it's actually whenever we have 1/2 divided by square root of 3 over 2, right? Oops, I'm sorry, I did that in the wrong direction, because it is the right number. It's 1/2 divided by the square root of 3 over 2. But that's where we have 1 over the square root of 3. But this is where we need sine to be 1/2 and cosine to be square root of 3 over 2. And we also need it to be negative. Well, tangent is negative in quadrant 2 and quadrant 4. It's going to be positive in quadrant 1 and 3. So we can have an angle in quadrant 2 and an angle in quadrant 4. where the sine is 1/2 and the cosine is the square root of 3 over 2. So the sine is 1/2, cosine is the square root of 3 over 2. So we would have either 5 pi over 6 which is also 150 degrees, or one in quadrant 4 that has the same reference angle. The reference angle here is 30 degrees. So we would see that here at 330 degrees, or 11 pi over 6. Okay, so it's really just getting used to working in the reverse direction, that is, knowing the trig value, what angle has it. So you should be able to go forward and backwards with the unit circle. Again, try to commit those to memory so that you don't have to rely on that and take up a lot of time during a test.